Okay, so continuing on to 5.4. So back to e to the x. So it's called the natural exponential function. All right, natural exponential function. All right, starting off with what we already know. We know the derivative of e to the x, the easiest derivative to remember because it's just e to the x. And if we incorporate the chain rule, so we're going to use e to the u. So then it's just e to the u times the derivative of u. That's the chain rule kicking in. What about integration? Well, this is going to be pretty straightforward. Both ways is e to the x. So if you're going to go back, because this is the antiderivative integration. And if you take the antiderivative going back to the original, which is still e to the x, so also no surprise here. Just don't forget the plus c. And when we write the chain rule version for integration, it's called u du substitution. E to the u du is just e to the u plus c. All right, so some of the properties that we will need. Let's see. Again, going back to pre-cal, when you first talk about inverse functions, let's say these are called the inverse properties. Going back to the fact that ln and e to the x cancel. So there's two versions. If e to the x is the argument, or the other way around, ln x is the argument, in either case, they're going to cancel. And then the next ones are called one-to-one properties. So these are especially useful for solving equations. This is number 3. E to the x equals e to the y, then x equals to y. The way I like to think about this one is if you have the same base on both sides, you can kind of visualize canceling. The log version, if you have the same logarithm on both sides, in this case ln of x and ln of y, then x equals to y. So same idea. The fact that you have the same log on both sides allows you to cancel. All right, so it's a good idea to just practice a little bit with the solving part. So in other words, if we run into equations, let's take a look at what we can do. So these are little mini examples, I guess you can call them. E to the x minus 1, and then equals to 1. And we're going to solve for x. Well, there's a nice rule that anything to the power of 0 is 1. So why do I bring that one to mind? Well, if we wish to cancel out e, we would need it to be on both sides. So in other words, this is wishful thinking right here. But what would you need to go in here for this to work? Well, we just said it. You would need to have 0. And now you can do canceling. So then this one and this one is gone. So then from here, you get x minus 1 is to 0, so x equals 1. So there you go. That was pretty easy. Again, because we know our properties. That's what makes it easy. Let's see, what else could we do? Oh yeah. Or let's say, let me give you options. Whatever you might think is easier. You can take the natural log on both sides. That's totally legal. You can do ln on both sides. So I'll even put it in a different color so you can see. You can put ln there. You can put ln there. That's totally legal. Apply logarithm to both sides. And then as a result, this is where the magic happens. Ln and e cancel, we had said. So then the only remaining part is x minus 1. And then what is ln of 1? Well, that's the exponent that gives you a value of 1. The exponent is 0. Or you can just put it in your calculator. Type in natural log of 1, and then the calculator is going to give you 0. And of course, takes you back to the same place. So whichever one you like, 2 different ways of doing the same thing. Let's see what else. All right, so let's try another one. Let's see. What about if we have e to the x plus 2x e to the x equals to 0? All right, so since this is an equation, we can always use the zero product property. What does that mean? Factoring, that's what it means. Zero product property looks like this. You do it without really thinking about it. If you have a product, A times B equals to 0, then what that means is that A equals to 0 or B equals to 0. And that's exactly what we do whenever you have an equation and then you factor the equation. When you set it equal to 0, then you get one of the answers from here and then the other answer from here. Because each one of these you set it equal to 0, that's called the zero product property. Okay, so normally you think about this one when you're working with quadratic equations or polynomials. Well, it works for everything. All right, so with that in mind, looking at this one, what can I factor out? Well, e to the x and e to the x, they both have that. So I can factor out e to the x. Which means that the part that goes inside, factoring is technically division, but I think it's easier with multiplication. So if I think about it with multiplication, I like to say fill in the blanks. e times something, that first blank is going to give you the original e to the x. So what should go there? 1. The second blank, what goes in the second blank? Well, if you factored out e to the x, what was left over? 2x. So now we can use the zero product property, going back to the idea that this one is going to be separate and this one is going to be separate, and each one is going to be equal to 0. E to the x equals to 0, and then the other one, 1 plus 2x equals to 0. So let's take care of this one really quick. It's pretty easy. X equals -1 divided by 2. So that's one of your answers already. Now, what about this one over here? E to the x equals to 0. Well, turns out that this one has no solution. How do I know that it has no solution? Well, we said e to the x is an increasing function. So let's bring back our little picture, the graph of e to the x. And it looks something like this. Oops, that's not good enough. Let's try that again. That's better. So e to the x is increasing. And it's increasing and it never touches the x-axis. So it will never be 0, in other words. So that's why it's no solution. We call this a horizontal asymptote. Horizontal asymptote. And that's why we have no solution. All right, let's see what else. Oh, well, I guess since we are already here, might as well look at options. Let's say you didn't remember the fact that e to the x had a horizontal asymptote and you still wanted to solve it using the operation of ln on both sides. Well, yeah, this guy is gonna cancel. So this works out pretty nice. But then if you put this in the calculator, the calculator is not gonna like you. It's gonna say error because it has no solution. All right. All right, so one more. So there's an important skill that we need to make sure we remember how to do. And that's changing from log form to exponential form. And we're going to see it in action on the next example. All right, so in this case, we want to solve for x. And we want to cancel away ln. So what we need to do is, anytime you want a logarithm to go away, so I guess let's put a little note here, note how to make any log So this trick works for any log. Go away. And the answer is exponential form. All right, so let's see. How does exponential form work, the switching back and forth? Well, maybe I can put it over here for you in case you forgot. So if you have y log ax, that's called log form. And if you're going to switch it over to exponential form, well, how does this work? When I learned it a long time ago, I learned it with little arrows. The base to the power has to equal x. So following the arrows, a to the power of y has to equal x. And that's how you switch it over. All right, so that means that if I'm going to switch it over, I need to know what the base is. We know that ln is logarithm with base e. And we have all the other pieces ready, so we can do our little switcheroo, and we can go back to our little arrows. To the power has to equal. In other words, e to the power of 6 is going to have to equal 9x squared. Divide both sides by 9. And then this cancels out. All right, let's see, it's doing weird stuff here. There we go. So that one is gone. That one is gone. So then what we have is just x squared. E to the 6 divided by 9. And then, of course, take the square root on both sides. Don't forget about the plus minus. That way we can cancel out. So then square root of the top, square root of the bottom, it'll be e to the third power divided by 3 plus or minus. Now, if you don't remember where I got the 3 from, square root, there's a 2. So you divide the inside number, it's inner over outer. 6 divided by 2, and that's how I got the 3. Alrighty, so that was our little review. Now, the main focus, derivatives. Okay, so let's bring back what we know already. E to the u is e to the u times u prime. And we also know ln. Derivative of ln, since e and ln are related to each other. They're cousins in a way. U prime over u. Okay, let's call it number 1. All right, so for the most part, these are going to be pretty straightforward. So we're going to take the derivative, which means u, because we're going to have to use the chain rule, u is going to be this guy right here. So then this guy right there, that's going to be u. So when you take the derivative, it's the same thing again, e to the u times the chain rule kicks in. The derivative of 2x minus 1 is just 2. And then typically we just, to make our answer look a little nicer, just put the constants in the front. All right, so that one was pretty straightforward. Number 2. Let's see, e and then x times natural log of x. X times natural log of x. Okay, so it's multiplication. So this won't cancel out. So it's not going to cancel out because the x is there. So if we're going to treat the exponent to be u again, then you're going to need to know its derivative. So let's go ahead and do the little side work. So then it's going to be u prime. Well, let's do it in written. It's going to require the product rule because you're multiplying. So how do you do product rule? So let's remember. Well, let me use this other way. It's easier to remember. Okay, so this was ln of x. There we go. So if you have f times g prime, it was f prime g plus f g prime. So in other words, f is x and g is ln of x. So let's take the derivative. So what's the derivative of x? Well, that's 1 times ln of x plus f, which is x, times the derivative of g. So what's the derivative of ln? 1 over x. All right, let's clean it up a little bit. So then this is ln of x plus 1 because the x's cancel. Okay, perfect. So now we can take the derivative y prime. So it's e to the u. So the original thing times u prime, which was ln of x plus 1. All right, and I would leave it like that. I don't think it requires any more simplification. We wouldn't gain anything by trying to multiply it out. It doesn't really simplify anymore. And let's see what number 3. So it's gonna be 1 over the square e to the square root of x. Okay, so right off the bat, the problem is that e is in the denominator, but we can easily fix that. Bring it upstairs, opposite on the exponent, which means just put a negative in the front. And that tells me that this is what u has to be. So this is telling me that u is gonna be negative x to the 1/2 power. And when I take the derivative u prime, this is gonna be negative 1/2 in the front, x, you're gonna subtract 1, so 1/2 minus 1 is gonna be negative 1/2. So then if we clean it up a little bit, you're gonna have a negative, and then you're gonna have 1, but in the bottom is gonna be 2, and x to the 1/2. Well, that's the same thing as square root, right? So in other words, negative 1 to square root of x. Okay, so now we're ready. So y prime is going to be e to the u. So the derivative is repeated the original times u prime, which we just finished doing on this side. And we can clean it up a little bit. We can send e to the negative square root of x back downstairs. So if we do that, whoops, I don't know why I put double prime. Okay, so if we do that, negative 1, and then everybody in the bottom, e square root of x, and then there was a 2, and then there was a square root of x. So something like that, roughly. All right. So far so good. Let's try one that is a little bit more complicated. E to the x plus 1 and e to the x minus 1. And we're going to take the derivative. Okay, so, well, let me bring back the little formula here. That way you can see what's going to happen. It was u prime over u. So that means u is the inside. If you look at u, the inside, and if you take its derivative, you would have to use the quotient rule. So that definitely works. But if you remember, the quotient rule is the harder version of the product rule. So let's not do it that way. And instead, you use properties of logarithms. So if we fix it a little bit before we try taking the derivative, logarithms, when you divide, you can subtract. It's called the quotient rule. Minus. Okay, so that looks pretty good right there. Now we can take the derivative, and it's two pieces individually that I can do. So that way on itself, this part is u when I do it, and then when I do this part by itself, this one is going to be u. So I'll just do it separately 2 times. All right, so it's u prime over u. Well, the derivative of e to the x plus 1 is very easy. It's just e to the x. And since 1 is a constant, that goes away. So this is just e to the x over e to the x plus 1. In other words, what just happened? Well, this was u prime over u. That's what happened. Same business over here. Derivative is e to the x, since negative 1 is a constant, over the original e to the x minus 1. All right. Now the issue that we're going to have is, even though this is technically correct, there's nothing wrong with this answer. But more than likely, this is not the answer that is going to be in the book or on WebAssign. So we can clean it up a little bit, do some simplification by algebra. All right, let's see. Let's get rid of, okay, let's see, right up there. Okay, let's get rid of this one. All right, because I need the space. And what we need is a common denominator. So you need the LCD. And the LCD, when you have two separate fractions, it's the product. So in other words, it's going to be e to the x plus 1 multiplied with e to the x minus 1. But if you FOIL it, you're going to get a nice answer. And as a matter of fact, you don't need to FOIL it, because this is difference of squares. This is a plus b and a minus b. And if you remember, that guy was a squared minus b squared. So for that reason, this is going to be the first one square. So if you square, you multiply exponents. That's 2x. Minus, if you square, 1 square is 1. All right, so let's keep that handy. We're going to transfer it over in a little bit. Now let's do the multiplication. Let's see. Well, I guess I can keep it with blue. This would be e to the x minus 1. And this one over here would be e to the x plus 1. Now, there's a special name for this. We did it towards the beginning of the semester. It was conjugates. So that's the trick for this guy right here. Conjugates. so let's do the algebra. And let's see what we get. So we know that on the denominator, the product is this little green box over here, e to the 2x minus 1. Now it's just a matter of multiplying the numerators. So let's take care of the first one. This one here, and then here. This one here, and then here. So you're going to distribute e times e to the x times e to the x. When you multiply, you add exponents. E to the 2x minus times negative 1 is just e to the x. Next one. But be careful, the next one has a negative in front. So it's going to be e negative e to the 2x. And then distribute the negative again. So that's why you get another negative. And this is going to be e to the x. Okay, so let's see which parts go together. So I guess combine like terms, in other words. Or actually, I can cancel stuff. I just noticed. Looks like this guy and this guy go away. And then these go together. So this one is negative e to the x and negative e to the x. That's 2 of them. So it'll be negative 2 e to the x. And then just the bottom stays the way it is. And that's about it. That's as pretty as we can make it look. We can't simplify it any further. Okay, let's see. Integration. All right, so we know the formula for integration. Again, very easy. E to the u du was just e to the u, but plus c. All right, so I guess let's call this one number 1. Number 1 for integrals. So this is the u du substitution. So this is going to be very straightforward at the beginning because the natural choice, right? If you just look at it, usually the challenging part of integration is knowing how to choose u, the substitution. Well, u should be that. Okay. So let u be 1 minus 2x. And then when you do du, the derivative is just negative 2 and then dx. But you have to replace equals for equals. So the fact that you have dx over here by itself, I need dx over here by itself. So for that reason, it's going to be du over negative 2. And that'll be dx. Okay. Now let's switch it out. We said this is going to be e to the u. And then this guy is du over negative 2. And constants, we factor them out. In this case, it's a negative 1/2. Now that that's out of the way, e to the u du negative 1/2. Formula says it's e to the u plus c. Replace what it was originally, which was 1 minus 2x plus c. Okay, that wasn't too bad at all. Pretty straightforward. Okay, number 2. All right, so little by little, it's gonna get a little bit, I'm not gonna say hard, just not as straightforward. So you're gonna have to do a little bit observation before you actually just jump in. All right, so by looking at it, your intuition would tell you that you should be, let's see if I can highlight. Nope, not that one. Let's see. All right, yeah, it lets me highlight. Okay, so you would want to think that that should be you. Well, not very good at highlighting. That part. So you would think that should be you. Okay, well, if we are careful instead, integration means that e is supposed to be in the numerator. So if we switch it, if we move it to the numerator, that means the exponent is going to be opposite. So let's not jump into it yet. Let's go ahead and fix that first, right? Oops, I forgot to. So that's, here we go. So then this is x squared dx. And then if you bring this guy upstairs, what should be the exponent? Well, it's opposite, right? So if it's opposite, if x cubed used to be negative, now it's going to be positive. If 1 was positive, now it's going to be negative. So it's opposite because you moved it, right? So if it's not so clear, let me do it for you over here on the side, like a little side note. All right, if you had 1 over e to the x, and then if you bring it upstairs, e to the negative x, that means that the exponent is opposite. The exponent is opposite. The fact that our exponent here was a little bit more complicated doesn't change the fact that this has to be the opposite of that. So that's why I did that first. So that's why I said it requires a little bit of observation before you just jump in and try to do it. All right, so now that we did our little prep work there, u is going to be x cubed minus 1 du. Take the derivative, 3x squared dx, and we're replacing equals for equals. So we require x squared dx, which is this guy over here. So 3 needs to go away. We divide it du over 3 x squared dx. Okay, very nice. Let's replace it. So this is e to the u, and then x squared dx was du over 3. And we said constants, push them out of the way in the front as a 1/3 e to the u du. And now very easy, 1/3 e to the u plus c, and put back what it was originally. It was x cubed minus 1. All right, let's see what else we have here. Let's see, that was number 2, number 3. All right, so I'm just going to give you a bunch of variety. That way, depending on which one you run into, you should be pretty prepared. All right, so again, it's starting to get ugly and uglier, I guess, but that doesn't really mean that it's going to be harder. It just means that you need to be more observant, be more careful. So then the trick that we wanted to use at the very beginning, where we automatically think that that should be you. Well, let me change it again. Okay, we were thinking that this is gonna take, oops, what happened to the 2? All right, so that's supposed to be a 2, okay. All right, so where you would think that you would be automatically that, right? Or it would be automatically that. If you try it, it's not gonna work, okay? And the reason it's not gonna work is because you're gonna be left with 1 plus e in the denominator. So if you're curious, you can give it a try and you're gonna see that it doesn't work. Okay, so similar to a trick that we used before, if by itself doesn't work, try the whole thing. So try the whole thing. So in other words, the whole thing will be all of that as u. And then let's see what happens. Okay, so du. So then when you take the derivative, it's the same thing again, but chain rule kicks in, times the derivative of x squared is 2x dx. Well, that looks pretty nice already, because if you look at it, it kind of matches the numerator over here. Let's just rearrange it so it looks exactly like it. So now it's exactly the same thing. All of this is all of that. So this works out pretty nice. Let's switch it out. So then this is du, and this is u. Du over u. This is a formula, and it's natural log. absolute value of u plus c. Okay. All right. So natural log absolute value u was 1 plus e to the x squared. Okay, very good. Okay, so a little note here. I've mentioned this before, but it's worth noting again because sometimes we forget and then we might get stuck. So it doesn't hurt to mention it again. If you forgot that this is a special case, this 1 over u du, because that's technically what we have over here, is the same thing as du over u. And if you forget that this is a special case, this is a formula that is the natural log. If you try it the other way, you're going to run into issues, right? What do I mean? Well, let's say you forgot and you say, oh, okay, move it to the numerator. Then this is negative 1. And then you do the antiderivative, which is add negative 1 plus 1. And then you divide by whatever the answer is. Well, that answer is 0. So the negative 1 plus 1. So in reality, what you would get is u to the 0 divided by 0. And nope, no good. Doesn't work. So that would tell you, that's like a little hint. Oh, this is that special case. This is a formula. All right. Let's see here. So at this point, it would be a good idea for you to practice. All right, so let me give you some. So you could pause and then give these a try. Okay, and one more. Okay, so integration. So you have a bunch of them here for you to practice. So I suggest give it a try, pause it before I show you how to do it. Okay, all right. Solutions. All right, I guess which one? Well, I guess A is easy. Let's handle the first one. Well, if you do a little bit of algebra, that's usually a good approach here. Again, instead of jumping in, just be observant. And this is to the power of 1/2. Power of 1/2. Well, when you have power over power, you multiply. X over 2. So now here the only possible choice, or I should say the obvious choice, is that should be u, x over 2. Du is going to be 1/2 dx. All right, so then I guess you can multiply times 2 because you do need the dx to be by itself right there, and I need it to be by itself, so you can multiply times 2, and as a result the 2 cancel, so you get 2 du equals dx. Okay, so now let's start swapping out everything. This is going to be e to the u, and then this is 2 du, but guess what? 2 is a constant. Throw it to the front. So it's going to be 2 e to the u plus c. Put back what it was originally, x over 2 plus c. All right, let's see. What was the other one? Okay, so that long one. Okay. Let's see here. B. All right. So it looks pretty ugly, but again, it only looks ugly. It's not really ugly. So going back to the idea that u would have to be either that guy or that guy. Well, it doesn't work if you choose it individually to be one of those. So if it doesn't work individually, use the whole thing. So which whole thing? You can use the bottom whole thing or the top whole thing, right? So you don't know unless you try. The bottom whole thing, let's see what happens with that one. All right, so it's e to the 2x minus e to the minus 2x, and then du. Okay, taking derivative, it's going to be chain rule a bunch of times here. Just be careful. E to the 2x, chain rule kicks in, so this is times 2. Minus, take derivative, e to the minus 2x, chain rule kicks in, times negative 2. And times dx. So just be careful because we have a bunch of stuff here. The whole thing dx right there. All right, so now let's clean it up a little bit. Put a 2 in the front, e to the 2x, and then the negatives cancel out over here because that negative and that negative are going to go away, so it'll be a plus 2. E to the minus 2x. And again, don't forget the whole thing, dx. All right, let's see how we're doing. Well, since we have to replace equals for equals, looking at the numerator over here, it looks very much the same except that we have an extra 2. So I guess let's make the 2 go away. Divide both sides by 2. So then du over 2. And now you get exactly what's going to match. So it looks like we chose correctly. The whole thing, the bottom worked instead of the whole thing, the top, choosing u to be the whole thing, right? So you don't know unless you try. I'm forgetting dx. There we go. So then we said that guy now matches exactly that guy right there. So let's swap it up. Okay, so this is going to be du over 2. And then you always have a 1. And the bottom was u. So you can slide out 1/2. Du over u. And there's that guy again. Natural log. Absolute value of u plus c. Okay, and u was all of that stuff right there. All right, that takes care of that one. Let's see, where's the other one? Part C. 1 divided by e to the, okay. Last one. 1 divided by, outside you got e to the x. 1 minus e to the minus x. And then the whole thing, power of 2, dx. All right, so usually when you have more than one e to the x, usually it's the majority of the time that you have to choose the whole thing. If you notice the little pattern. So with that in mind, a good place to start is try the whole thing. See if that works. Okay, so let's see, 1 minus e to the negative x. And then we'll see what happens. Du, take the derivative, negative e to the negative x. Chain rule kicks in, times the derivative of negative x is negative 1. Then dx. Well, that negative and that negative go away. So what do I have left? I'm gonna have dx and e to the negative x, but if it's negative, I can bring it downstairs. That way, it'll be dx over e to the positive x. And I think that matches if I rearrange this part with this part. So let's rearrange things. 1 minus e to the negative x power of 2. And then I said I was going to put dx together with e to the x. Now it matches exactly. So that part and that part right there. Okay, so then this is 1 over u squared. And then this one was simply du. Actually, this is pretty nice. This is a negative 2 if you move it upstairs. And antiderivative, add to the exponent and then divide. So then if you add 1, so you're going to add 1. So that'll turn it u to the negative 1 divided by negative 1 plus c. Bring it back downstairs. Negative 1 u plus c. And then let's bring back what it was originally. Let's see, u was the 1 minus e to the minus x. Okay, so that's going to wrap it up. All right, so then let's see what's next on our sequence. Other bases. So it turns out that we're going to be able to do derivatives and integrals for things that look like this. So we know e to the x, but what if it's anything else? A to the x. So we're going to do stuff like that. Okay, so I think that's section 5.5. All right, so we'll go ahead and stop right there for now.